NASA's James Webb Space Telescope has just revealed a massive light-year-long stellar jet at the far edge of our Milky Way, fired by a newborn star. Why do young stars launch jets like this, and how do they shape future planets? In this documentary, we follow Webb's journey, exploring why it was built for invisible infrared light, how it unfolded, and what it discovered. We'll visit the first galaxies, read the skies of distant worlds, and look inside planet-forming disks and star nurseries. Then we return to that giant jet to learn how stars grow and where we fit in the story. For thousands of years, people have looked up at the night sky, wondering about the stars and what they mean. Long ago, early astronomers made maps of the sky, told stories about the stars, and tried to understand the patterns they saw. Over time, we made tools to help us see farther. First simple glass lenses, then telescopes. Each new tool showed us things in space that people before us could not even imagine. As technology got better, we learned even more about space. The invention of new types of telescopes, like the reflecting telescope and the launch of the Hubble Space Telescope, changed how we studied the universe. But even as we learned about faraway planets and galaxies, we found new questions. What happened at the very beginning of time? How did the first stars start to shine? Is there life anywhere else in the universe? To try to answer these big questions, scientists and engineers imagined a new kind of telescope, one that could see farther, deeper, and in types of light our eyes cannot see. This dream became the James Webb Space Telescope, or JWST. Its shiny golden mirrors are ready to catch the faintest light from the early universe. Building Webb took many years and lots of teamwork. People from different countries worked together, solving problems and waiting for the day it would launch. On the day Webb was launched, people everywhere watched with excitement. When the telescope was set up in space, it was a huge success for everyone who helped make it happen. Now, Webb travels far beyond the moon, looking back to the beginning of everything and finding secrets that are billions of years old. Its job is to study where the universe came from, search for new worlds, and learn about space and time. Scientists everywhere are excited. Every new picture and discovery from Webb could change what we know about space. Webb is not just a tool for scientists. It shows how curious people are, how we work together, and how much we want to understand the universe. Come with us as we start this journey through space, using Webb's amazing vision. Together, we will explore the universe and see the story of how everything began. Please like this video, subscribe to our channel, and join us in exploring space. Let us know in the comments what space mystery you hope Webb will help solve. Your support helps us make more space videos and share new discoveries with you. Let's explore deep space together and find out what secrets the universe is hiding. Before the James Webb Space Telescope, there was Hubble, a famous telescope in space that changed how we see the universe. Launched in 1990, Hubble sent back amazing pictures of faraway galaxies, colorful clouds of gas, and the life cycles of stars. These discoveries changed what we know about space and inspired people all over the world. But even though Hubble was powerful, it couldn't see everything. There are thick clouds of dust in space that block Hubble's view of the universe's earliest times. Scientists wanted a new telescope, one that could look even further back, to when the first stars and galaxies were born. The idea for Webb started many years ago as a way to go beyond what Hubble could do. Scientists and engineers from different countries worked together to imagine a telescope that could see heat or infrared light, helping us find secrets hidden since the universe began. Building Webb was a huge challenge. It meant inventing new materials, creating new ways to solve problems, and making tools sensitive enough to spot the faintest heat from the farthest galaxies. Webb's main mirror is huge, about 6.5 meters across, made from 18 gold-covered pieces that fit together like a puzzle. Gold is great at reflecting heat, which is perfect for Webb's job of catching the faintest signals from the edge of the universe. To see these very faint heat signals, Webb has to be colder than Pluto. That's why it has a sunshield the size of a tennis court, 5 thin layers that block heat from the sun, Earth and Moon. Webb's cameras and tools are kept at -223 degrees Celsius. This lets them pick up the tiniest bits of heat from the oldest galaxies and stars. To stay this cold, Webb orbits far from Earth at a special spot in space called the second Lagrangian point. Here, it can keep a steady, cold position, away from the heat of our planet and the Sun. Webb is a true team effort. NASA, the European Space Agency, and the Canadian Space Agency all work together, bringing thousands of people from around the world. The design took many years and people from many countries. Teams had to solve tough problems, like staying on budget, fixing technical issues, and making sure every part was perfect. Webb's goals are just as big as its design: to see the first stars and galaxies after the Big Bang, to watch how stars and planets are born, and to look for signs of life on planets far away. Webb will search for the first light in the universe, map how galaxies come together, study how stars and planets form, and look for the building blocks of life on distant worlds. Webb is more than just a telescope. It's like a time machine and a cosmic detective. It shows what people can do when they dream big and work together. Now that Webb has started its mission, we're ready to discover answers to some of the biggest questions. Where did we come from? Are we alone in the universe? And what is our place in space? The search to understand where we came from and if we are alone has entered a new chapter. With Webb, we are about to discover the universe's deepest secrets. Before the James Webb Space Telescope could be launched, people spent years getting everything ready at space centers around the world. Engineers and scientists worked carefully, building and testing each part to make sure it would work perfectly in space. In the last days before launch, the telescope was moved very carefully to the launch site in French Guiana, South America. Every step was watched closely, and every bump or shake was measured to make sure Webb arrived safely and undamaged. At the Guiana Space Center, teams wearing clean suits did final checks on the telescope. There was a feeling of excitement in the air as the Ariane 5 rocket was prepared for its important mission. Launch day finally came, December 25th, 2021. As the sun rose, the rocket stood ready on the launch pad, surrounded by early morning mist. All around the world, scientists, families, and space fans watched and waited, hoping for success. The countdown began in mission control. Years of hard work came down to these last seconds. With a loud roar, the Ariane 5 rocket lifted off, carrying Webb into space. People cheered in control rooms and at home. But for the team, the real challenge was just starting. Webb's trip to its new home in space would be full of risks. Over the next month, Webb traveled almost 1 million miles away from Earth. On the way, it had to do a series of tricky moves. Each one was very important for the mission to work. The first step was to open the solar panels, which gave Webb power. Next, the huge sunshield, a special cover with 5 thin layers, slowly opened up, with every step watched closely by the team. Engineers watched live data on their screens, ready to fix any problem. People everywhere followed the news, hoping everything would go well. Next, the smaller mirror moved into place, and then the main golden mirror, made of 18 pieces, carefully unfolded. Each step was a big achievement for the team. Around the world, scientists, students, and the public watched in amazement. News and social media shared every success, and people celebrated as each step worked. At last, after weeks of careful work, Webb reached its spot in space called the L2 point. The team then began the careful job of lining up the mirrors, which had to be done with incredible accuracy so Webb could see clearly. And then came the moment everyone was waiting for: first light. The first pictures from Webb were more than just images. They were windows into the past, showing a universe more colorful and mysterious than we ever imagined. One of the main goals of the James Webb Space Telescope is to look far back in time, to see the very first galaxies that formed after the Big Bang. This is like opening a window into the distant past. letting us see what the universe looked like more than 13 billion years ago. But how can Webb look back in time? Light does not travel instantly. It takes time to move across space. So when we look at things that are very far away, we are actually seeing them as they were a long time ago. The light from distant galaxies has traveled for billions of years to reach us. And as the universe expands, this light stretches and becomes redder. As we peer deeper into the universe, the faintest glimmers of ancient galaxies begin to appear, each one holding clues to the earliest days of space. The universe is constantly expanding, and with every burst of light, we uncover new mysteries waiting to be explored. The James Webb Space Telescope is designed to see this faint, stretched-out light. Its special infrared cameras can spot galaxies that are billions of light-years away, meaning the light left those galaxies almost as long ago as the universe has existed. The James Webb Space Telescope orbits silently, always searching for new wonders in the vastness of space. Each observation brings us closer to understanding how the universe has changed over billions of years. With every new image, Webb helps us piece together the story of our cosmic origins. To find these ancient galaxies, scientists use careful methods. They look for tiny, faint spots of light in Webb's pictures, measure how much the light has stretched, and check their distance with more observations. In mission control, scientists carefully study the data, eager to unlock the secrets hidden in Webb's discoveries. Telescopes track the night sky, following the faint signals that reveal the universe's distant past. What Webb has found is amazing. It has seen galaxies that formed only a few 100 million years after the Big Bang, much earlier than scientists expected. These discoveries are changing what we know about the history of the universe. These early galaxies are brighter and more developed than anyone thought they would be. This means stars were forming very quickly in the young universe. Scientists now have to rethink how fast the universe became filled with light after the Big Bang. Imagine finding ancient cities that are much older and more advanced than anyone believed possible. Webb's discoveries are like that. Finding grown-up galaxies when the universe was still very young. Like ancient cities uncovered in the desert, Webb's findings reveal the unexpected complexity of the early universe. Each discovery is a step closer to understanding how galaxies and stars first came to be. Artists and computers help us picture what these first galaxies looked like. Groups of stars and gas swirling together, joining and growing in the darkness of the early universe. The excitement among astronomers is easy to feel. Every new image from Webb is eagerly awaited, as scientists hurry to study the data and share what they learn. Celebrations in the lab mark each breakthrough as scientists share the excitement of new cosmic revelations. In control rooms around the world, teams watch as Webb's discoveries unfold in real time. These discoveries are not just changing textbooks. They are opening up new ways to understand how the universe changed over time, and how the first stars and galaxies shaped everything that came after. The journey through the cosmic dimension continues, with each moment bringing new insights into the universe's history. Webb is not just looking at the past, it is helping us understand it in new ways. The telescope's discoveries are helping us put together the story of the universe's first days, showing that things were happening much sooner than we thought. As we keep exploring these ancient times, every discovery helps us answer some of the oldest questions people have asked. How did the first galaxies form? What was the universe like at the very beginning? And what does this tell us about where we come from? Every cosmic display Webb captures adds another piece to the puzzle of our universe. Webb's golden mirrors keep looking deeper, finding secrets that have been hidden for billions of years. The story of the first galaxies is just beginning, and with every new discovery, we learn more about our place in the universe. As we travel through the vast expanse of space, we are reminded of how much there is still to discover. The wonders of deep space inspire us to keep searching for answers to the universe's greatest mysteries. Beyond our solar system, there are thousands of planets circling other stars. Some are hot and stormy, while others are mysterious and hidden. For a long time, just finding these distant worlds was a huge achievement. Now the James Webb Space Telescope is helping us learn what these faraway planets are really like by studying the air around them. Imagine a planet with bright red skies, or a place where it rains melted glass. Thanks to Webb, scientists can look at the air on these strange worlds and search for things that might mean life could exist there. Scientists look for water vapor, methane, and carbon dioxide in these atmospheres. These are important because they could be signs that a planet might support life. Each type of gas leaves a special mark in the light that passes through the planet's air, like a fingerprint. Webb uses a clever method to study these gases. When a planet moves in front of its star, some of the star's light shines through the planet's air. By breaking this light into a rainbow of colors, Webb can spot which gases are there, because each one changes the light in its own way. It's a bit like scanning a barcode to find out what's in the air. The pattern of colors tells scientists which gases are present on these distant worlds. In 2022, Webb found water vapor in the air of a giant planet called WASP-39b, which is over 1,100 light-years away. This planet is too hot for life, but finding water shows how sensitive Webb is to tiny details. Webb also found carbon dioxide in the air of another planet, WASP-39b. This was the first time this gas was seen so clearly on a planet outside our solar system. These discoveries are more than just exciting news. They help us get closer to finding signs of life called biosignatures in space. Scientists everywhere are now looking at Webb's data, searching for hints of oxygen, ozone, or even more complex gases that might mean something is alive. Webb can also study rocky planets and mini-Neptunes, planets that are very different from anything in our solar system. Some of these planets are in just the right spot for liquid water, which is important for life. Imagine a planet with purple sunsets, or a world covered by endless oceans. Webb's discoveries help us picture what it might be like to stand on these faraway shores. The search for life is not just about finding another Earth. It's about learning how many different kinds of worlds exist in our galaxy and what makes each one special. Webb is carefully studying these alien skies, bringing us closer to answering one of the oldest questions. Are we alone in the universe? Every new discovery, every bit of information is a step towards solving the mysteries of space. The dream of finding another Earth, or even simple life beyond our planet, feels closer than ever. As Webb keeps looking at the skies, it's not just collecting facts, it's helping us imagine and inspiring new generations to look up and wonder what amazing worlds are out there. All across space, new planets are born in huge, spinning clouds of gas and dust that circle around young stars. These clouds, called protoplanetary disks, are like nurseries where new worlds begin to form. The James Webb Space Telescope helps us see inside these dusty disks. Its special cameras can look through the dust and show us details we could never see before. Inside these disks, tiny bits of dust bump into each other and stick together. Over time, they grow into pebbles, then rocks, and finally into bigger objects called planetesimals, the first building blocks of planets. Over millions of years, these building blocks crash together and join up, making larger and larger bodies called protoplanets. These protoplanets sweep up more material as they move around their star. Webb has taken amazing pictures of these disks. In some, we can see gaps and rings. These are made by new planets as they clear paths through the dust while they grow. Some disks have spiral arms, where dust and gas are pulled toward growing planets. Others have bright spots, showing where new planets are forming right now. Webb can also find important chemicals in these disks, like water, carbon dioxide, and methane. These are some of the basic ingredients needed for life as we know it. By studying the light that passes through these disks, scientists can figure out where ices and organic molecules are found. This helps us learn how oceans and atmospheres might form on new planets. Not every planetary system is like ours. Webb has found disks with giant planets close to their stars, and others with many rocky worlds packed tightly together. These discoveries show that making planets is a common process, but the results are very different. Some become hot gas giants, some become rocky super-Earths, and some are unlike anything in our solar system. Webb's ability to study young stars like L1527 lets us watch new worlds being born as a baby star gathers material from its disk. By watching these places where planets are forming, scientists can see the same steps that built our own solar system billions of years ago. Webb's discoveries help us answer big questions. How many planets like Earth are out there? What does it take for life to begin? And how special is our own planet? Every new discovery brings us closer to understanding how worlds are made, from tiny grains of dust to giant planets. This story connects us to the stars, to the beginning of our own home, and to the many worlds still waiting to be found in our galaxy. As Webb keeps working, we get to watch the story of creation unfold, one new world at a time. Stars are like the building blocks of everything in space. They make the elements that form planets, plants, animals, and even us. But how do stars actually begin their lives? Every star starts out in a huge cold cloud made of gas and dust. These clouds are called stellar nurseries because they are places where new stars are born. These nurseries are found all over galaxies, just waiting for the right moment to create new stars. To learn more, the James Webb Space Telescope looks deep into these nurseries, helping us see how stars are made. Inside these clouds, gravity slowly pulls the gas and dust together, making thick clumps. As these clumps get bigger, the middle gets hotter and hotter until it is hot enough for a reaction called nuclear fusion. This is what makes a star shine. Webb's special cameras can see through thick dust that hides these early steps from normal telescopes, showing us the hidden story of how stars are born. One of the most famous pictures in space is called the Pillars of Creation. This is a place where many stars are being born, about 7,000 light-years away. The Hubble telescope took a beautiful photo of it, but Webb's new images show even more detail. In Webb's pictures, we can see baby stars coming out of thick columns of gas. Their light makes holes and bright spots in the clouds around them. These pillars are both where stars are born and where some stars end their lives, shaped by the strong energy from other stars nearby. Webb's special view lets us see through the dust and gas, showing the new stars hidden inside the pillars. As these young stars grow, they send out strong winds and jets that shape the clouds around them. This can help make even more stars, or sometimes blow away the gas so no new stars can form in that spot. By watching these young stars, scientists learn about the very first steps of star formation. They can see how stars pull in more gas and dust, and how they push away what's left with their strong winds. The life of a star is a long journey. Big stars burn bright and live fast, ending in huge explosions called supernovae. Smaller stars, like our Sun, can shine for billions of years. Webb helps scientists follow these life stories by looking at groups of stars of all ages, from brand new stars to very old ones, all in the same nursery. This is an important part of learning how stars like our Sun were born. When big stars die, they spread important elements like carbon, oxygen, and iron into space. Webb's pictures of exploding stars and star-making regions show how this recycling helps make planets and life possible. Webb also studies the Tarantula Nebula, a huge area where many stars are forming in a nearby galaxy. This is one of the busiest star-making places close to us, and it's a great spot to learn how stars form in different ways. In the Tarantula Nebula, Webb has seen how gravity, light, and movement all mix together, helping us understand why some places make lots of big stars and others only a few. Webb's pictures of the Tarantula Nebula have shown thousands of young stars we never saw before, and the complex web of gas and dust shaped by their strong energy. By comparing different star nurseries, scientists are figuring out the main rules for how stars are made, and sometimes finding surprises that change what we thought we knew. Scientists all over the world use Webb's data to make computer models, test new ideas, and discover how stars help shape galaxies. From the famous pillars of creation to the wild Tarantula Nebula, the James Webb Space Telescope is giving us the clearest view ever of how stars are born. Every new discovery helps us understand space and our own beginnings, reminding us that the story of stars is also our story. The story of stars is full of creation and destruction, of light and darkness, and it keeps changing with every new picture Webb sends back to Earth. When new stars are born, things can get very dramatic in space. One of the most exciting things that happens is the creation of stellar jets. These are fast, narrow streams of gas that shoot out from baby stars at amazing speeds. These jets can stretch for many trillions of miles, cutting through clouds of gas and dust around the new star. They often look like bright beams of light, and sometimes you can see glowing spots where the jet crashes into space material. One famous example is called Herbig-Haro 211. It's a group of very young stars, about 1,000 light-years away from us, in a part of the sky called Perseus. The James Webb Space Telescope has taken amazing pictures of this huge jet, showing details we've never seen before. In these pictures we can see shockwaves like ripples, where the jet hits the gas and dust around it. These areas glow brightly and look like knots or bumps along the jet. But Herbig-Haro 211 is just one example. Webb has found many other jets from young stars, and each one looks a little different. Some jets are straight, while others twist and turn, shaped by invisible forces like magnetic fields and the movement of the stars themselves. These jets are important because they help young stars grow. As a new star forms, it pulls in gas and dust from a spinning disk around it. The jets act like a safety valve, letting out extra energy and helping the star stay together as it gets bigger. Without these jets, the baby star could spin too fast and break apart. The jets make it possible for more material to fall onto the star, helping it grow and shaping what it will become. Webb's special cameras can see through thick clouds that hide these jets from regular telescopes. This gives scientists a brand new look at the earliest, most hidden steps of how stars are born. Scientists use these new pictures to test their ideas about how jets start. Things like magnetic fields, spinning, and the way the star and its disk interact all help shape these amazing space streams. Some jets are so strong that they can squeeze nearby clouds of gas, starting the birth of even more stars. This can set off a chain reaction, making new stars across huge areas of space. By studying jets like Herbig-Haro 211, scientists are learning just how busy and lively the places where stars are born can be. Webb's discoveries are helping us improve our understanding of how stars come to life. Even the calmest-looking parts of space are full of energy and action, all working together in the grand story of how the universe creates new stars. The James Webb Space Telescope has already changed how we see the universe. But its work is just beginning. Every day, Webb looks farther into space, collecting new information that will help us make discoveries for many years. Each new picture Webb sends back, and every bit of data it collects, gives us new things to think about. Webb is not only helping us answer old questions, it is also giving us new mysteries to solve, making scientists rethink what we know about space. So what comes next for Webb and for us? The telescope will keep searching for the first stars and galaxies, hoping to find out when the universe first began to shine. Webb will also look at the atmospheres of planets far from Earth, searching for things like water, methane, and other gases that could mean life is possible. Its tools are so sensitive, they might one day find signs of life on other worlds. Scientists will use Webb to look at fainter and more distant objects, and to learn more about the mysteries it has already found. Every discovery will lead to new ideas and new missions. Every discovery will lead to new ideas and new missions. Webb's information will be shared with scientists all over the world, helping everyone work together and make new discoveries faster. The real value of Webb will be in the new questions it helps us ask, not just the pictures it takes. The search for the first stars and galaxies will go on, as scientists try to learn how the universe changed from darkness to light. Webb's work will help us understand the story of the universe from its earliest days. Webb will also study how stars are born and die, how planets form, and how galaxies change over time. Each new observation helps us learn more about where we come from. By looking closely at the air around distant planets, Webb will help us find out which ones might be able to support life. Maybe one day it will even find clear signs that life exists somewhere else. Webb's discoveries will help guide future space missions, showing scientists where to look and what to search for as we try to find life beyond Earth. Even after its main mission, Webb will inspire new and better telescopes. Scientists are already planning bigger and more powerful observatories, using what they learn from Webb to push technology further. New telescopes like the Nancy Grace Roman Space Telescope, the European Space Agency's Ariel mission, and others in the future all build on Webb's design and discoveries. One day, we might have telescopes that can take pictures of planets like Earth, or even find signs of advanced life. The search for life in the universe is just beginning. As technology improves, future telescopes may find planets with oceans, land, and even chemical signs of life. Webb is helping us get ready for these amazing discoveries. The James Webb Space Telescope is more than just a tool for science. It shows our endless curiosity, our wish to explore, and our need to understand our place in the universe. Webb reminds us that the universe is full of wonders, waiting to be found, and that every answer leads to more questions. Webb's mission shows what we can do when we dream big and work together. As Webb keeps watching the universe, looking deep into space and time, it carries the hopes and dreams of people everywhere. Its golden mirrors reflect not just the light of faraway stars, but also our endless curiosity. Its golden mirrors reflect not just the light of distant stars, but the boundless curiosity of humanity. The discoveries still to come will change how we understand the universe for a long time. Webb is not just searching the stars, it is inspiring us all to look up, to wonder, and to keep exploring, It is a golden eye, always searching, always revealing, and always inspiring us to look up and wonder. From the very beginning of the universe to the way planets form today, the James Webb Space Telescope helps us see our universe in more detail than ever before. It lets us look back in time and understand how everything began. With every picture, Webb shows us more of the universe, huge clouds of gas, spinning galaxies, and the faint light from the first stars. These discoveries are not just for scientists, they help all of us learn where we come from. Webb has shown us galaxies forming quickly, strange new worlds, and stars being born in clouds of dust. Each new thing we learn is like adding a piece to the puzzle of our universe. The telescope is the result of hard work by many people, scientists, engineers, and dreamers who wanted to know what is out there. Their work inspires young people everywhere to look up and ask questions about the stars. Webb has helped us learn more and made us even more curious about the universe. Its golden mirrors reflect not just faraway worlds, but also our hopes and dreams. Every new discovery reminds us that the universe is huge, full of surprises, and there is still so much to find. Webb reminds us that we are part of something much bigger, a universe that is always changing and full of mysteries we have yet to solve. From the quiet birth of stars to the swirling clouds around distant planets, Webb's discoveries connect us to the story of the universe. We are watching creation happen and are part of a great adventure through space and time. Our journey to learn more is not over. With telescopes like Webb, we will keep making new discoveries and finding answers to big questions about space. As we look ahead, Webb's mission lights the way for new explorers, new questions, and new inventions. Its work will inspire future missions and discoveries that will change how we see the universe. Thank you for joining us on this amazing journey. If you liked learning about the James Webb Space Telescope, please like this video, subscribe for more space stories, and share your thoughts in the comments. Your questions and support help us keep exploring. Together, we can keep asking big questions and enjoy the wonders of space. Your support lets us keep sharing new discoveries, explain the secrets of space, and bring you the latest news about the universe. As Webb looks deeper into space, remember, every discovery is a step forward for everyone. The universe is not just out there, it is part of us, calling us to dream, learn, and reach for the stars. Keep looking up,